In section 4, we go back to this word arithmetic, but now we're talking about series, not sequence. So arithmetic series takes an arithmetic sequence and adds all the numbers together in that sequence. So if I wanted you to add up all the numbers from 1 to 100, that's actually an arithmetic sequence. 1, 2, 3, 4, and so on, right? That's an arithmetic sequence. We're adding 1 each time, all the way up to 100. And we learned that we can reverse those numbers and add up all the columns. And we'd get 101 each time. How many times do we get 101? 100 times. So what I have is 100 times 101. But that's like I just added up all of these numbers twice. So that means I have to divide by 2. And we wound up coming up with a formula for this. What was it? N minus 1? Yeah, it's n plus 1 over 2. This is the formula for adding up all the numbers from 1 to whatever number you want. Right? So the answer to this problem is 50-50. Once you plug in 100 here. 100 times 101 is 10,100 divided by 2, and you get 5,050. So actually we've been doing what this section is going to ask us to do since the chapter started. This is a series. It just means add up all the numbers that are in an arithmetic sequence. So let's take a look at this example. It says the first 4 rows of chairs are set up for a meeting, and they're showing you what those first 4 rows of chairs looks like. This person right here in the purple has a serious problem with crooked chairs, so she's going around and fixing them. The seating pattern is to continue through 20 rows, it says. So how many chairs will there be in all 20 rows? Which we do. Add up all the seats in all the rows. Yeah, that's right. So the first thing I want to do is kind of observe what's going on in this picture. This would be row number 1. This is row 2. This is row 3. This is row 4. And so on. We continue all the way back to row number 20. Now, what do we notice that's going on in the rows? Each row adds 1 more chair. That's right. So we are starting with how many chairs in the first row? 4. And then how many chairs will be in the second row? And we're trying to add all these things together. So 4 plus 5 plus 6 plus 7 plus 8 plus and so on, all the way up to the 20th row. How many chairs will be in the 20th row? There's 4 chairs in row 1. There's 5 chairs in row 2. There's 6 chairs in row 3. So how many chairs are there going to be in row 20? 23. So we're adding up all the numbers from 4 to 23. So based on what we did with, we're adding up numbers from 1 to 100, what should we do now? What? Okay, we can't use the equation here because the equation that we know, the n times n plus 1 divided by 2, works for numbers from 1 to whatever number we want. We're not starting at 1, we're starting at 4. So we can't use n times n plus 1 over 2. But what we can do is do what we did to develop that rule for 1 to whatever we want. Yeah, so rewrite all the numbers underneath in reverse order. 4, this will be 23, 22, 21, 20, 19. And now we can add all these numbers together like we did before. What do we get each time? 27. How many times are we going to get 27? 20 times, because there's 20 rows. And then what are we going to have to do with that? Divide by 2. You don't need a calculator here. You have 20 times 27 divided by 2. That's true. And probably you don't know what 20 times 27 is. But you do know what 20 divided by 2 is. And then you do know what 10 times 27 is. So there's going to be 270 chairs. So we could actually come up with a pattern just after seeing this one example right here. We could come up with the rule for any number of rows if we wanted to continue this thing. Based on what you see here, if I wanted n rows, what could I write? N times, look at what we have here. N plus, if this is 20, then that's 20, and I needed 27, 7 over 2. So now I have a rule for this particular situation right here. This rule does not work for every situation, but it works for this situation. So now if I wanted 68 rows, I could put 68 here, and then do that math and find out how many chairs there's going to be. So that's what this procedure right here allows us to do. It's a really powerful thing to be able to do that, and then look at that, and then say, oh, well, I could just turn this into that, based on what I know from what happened with this. Okay? So go back over here, and there's your answer, 270 chairs. Okay, so in this section and the next section also, we're working with series, the last two sections for the chapter. Series just means the sum of all of the terms in a sequence. If they tell you to add up all the numbers from 1 to whatever, that's a series. You're adding the numbers together. A sequence just has a bunch of numbers. The series adds those numbers. A finite series, that's how you pronounce this word right here, finite, is a series with a first and a last term. In other words, the sequence ends. That's what finite means, something that ends. Infinite means something that doesn't end. So an infinite series is a series that does not end. And finally, arithmetic series. Just like arithmetic sequence, an arithmetic series is a series whose terms form an arithmetic sequence, and then we are going to actually add all of those terms together. So there's not much new in this section, except for we are now adding the terms together once we've generated the sequence. So how to find the sum of an arithmetic series? There's actually two formulas that you can use. We're going to use one more than the other, but you can use both. You will always be given the first term in your series or in your sequence. You're always going to be given that. And either the common difference or the last term. You can use the regular equation that we've been using, this guy, a sub n equals a sub 1 plus d times n minus 1. We've been using that to generate the terms of the sequence. You can use that to find n if you're not given n. And n is the term number, the number of terms in this case. So if you are given in the problem, if you are given the common difference and the first term, and that's it, then you can find the sum of all the terms, and that's what this is representing. The sum of the 10 terms, or whatever, is equal to the number of terms divided by 2 times 2 times the first term plus n minus 1 times d. Or you could write d times n minus 1 like we normally write up here. If we're given the last term and the first term, then you're going to write s sub however many terms it is that you're adding together equals the number of terms that you're adding together times the first term plus the last term divided by 2. And before I go any farther, you've seen this before. What is that? If I take two things and add them together and then divide by 2. If I take two things and add them together and then I divide by 2, what is that? The mean, which is another word for what? The average. Yeah. It's the average of the first and the last term here, multiplied by the number of terms. And that will give you the sum as well. So for example, find the sum of all of these here. We have 12 plus 19 plus 26 plus a bunch of other terms all the way up to 180. This as a sequence would be 12, comma 19, comma 26, comma a bunch of other terms all the way up to 180. Is this an arithmetic sequence? Yes, because each time we're adding how much? 7. So even though they didn't specifically say that we had the common difference, we now know that the common difference, D, equals 7. We also know the first term, which is a sub 1, which is 12. And they even gave us the last term, a sub n, which is 180. We can use either. Most of the time, this is the one that you're going to want to use. You're going to try to get all the information you need to use that one. We already have a sub 1, we already have a sub n. What we don't have is how many terms there are in this series that we're adding together. Right? Okay. So that means we're going to use this equation right here, our usual equation for a sequence, and plug in everything that we know. We know a sub n, what is it? 180. Equals, we know a sub 1, what is it? 12. Plus, we know D, what is it? 7 times, do we know n? No. That's what we need. We need to know the number of terms that are in this series so that we can use that formula. All right, so just solve for n. What should we do? You can distribute, or you can subtract 12 from both sides and get 168 equals 7 times n minus 1. And then what? You could distribute, or you could divide both sides by 7. And what is 168 divided by 7? Is it 24? Okay. So we have 24 equals n minus 1. So we add 1 to both sides and we get 25 equals n. So that means that there's 25 terms in this series that they're asking us to add together. And now we know everything that we need to know to use this formula right here. And notice, even if we wanted to use this formula over here, we had a sub 1 and we had D, but we did not have n. So we had no choice. We had to do this to find n. But now that we know n, we can go S sub what? 25 equals 25 times 12 plus 180 divided by 2, the average of the first and last terms. So 12 plus 180 divided by 2, we're looking at, what, 96? Is it? Okay, so we have S sub 25 equals 25 times 96. So that's 100 short of 2,500, so 2,400. S sub 25 equals 2,400. So that means if I were to write out all of these numbers right here and add them all together, I would get 2,400 as my answer. That's what this formula right here does for us. If we use this one over here, we would basically follow the same process, and we would still wind up with 2,400. So which one looks more complicated to you, the first one or the second one? The first one looks more complicated, which is why most of the time we prefer to use this one, because we have the same information anyway. All right, we have another problem here. Find the sum of the even integers from 2 to 100. What are we going to do? Write what we know. What do we know? We know the first term, so a sub 1 equals 2. What else do we know? The last term, a sub n equals, yes, 100. What else do we know? So the common difference is 2, so d equals 2. What don't we know? We don't know n, technically. But think about it. How many even numbers are there from 2 to 100? Is there 50? Or is it 49? Or is it 51? It's one of those three, though, isn't it? Yeah, for sure. So what about the sum of the even numbers from 2 to 10? 2, 4, 6, 8, 10. That's 5. What about the sum of the even numbers from 2 to 20? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So it's 50. But let's check that to make sure. We just use the same equation right here. We have a sub n, which is 100, equals our first number, which is 2, plus our common difference, which is 2 times n minus 1. We subtract 2 from both sides. 98 equals 2 times n minus 1. Divide both sides by 2. 49 equals n minus 1. And then you add 1 to both sides. N equals 50. Came out of my mouth. 100 equals 2 plus 2 times n minus 1. I'm just substituting into this formula. I subtracted 2 from both sides. 98 equals 2 times n minus 1. Divided both sides by 2. 49 equals n minus 1. And then I added 1 to both sides. N equals 50. Now we can use our sum formula here. S sub 50 equals 50 times 2 plus 100 divided by 2. So we're looking at 51 times 50, which is 2,550. Okay, random question here. Will the sum of even numbers always be even? If I add up some even numbers, am I going to get an odd number as an answer? No. Sum of even numbers is even. What about... Yes. What about if I add up a bunch of odd numbers? Is that answer going to be odd? Can it be odd? It could be odd, but it doesn't have to be odd. It could also be even. All right, a company pays a $10,000 bonus to salespeople at the end of their first 50 weeks if they make 10 sales in their first week. I hope these are not like vacuums or something. They must be like houses. And then improve their sales numbers by 2 each week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did the salesperson make in week 50? Or in all 50 weeks? This is a series problem. So the question is, what do we know? They start with 10. How do you know? Right. The important thing here is that one salesperson qualified for the bonus with the minimum possible number of sales. That's a real go-getter right there. Sell as little as he possibly can. So how many sales did this guy make in his first week? 10, or her first week, I should say. So that means that A sub 1 equals 10. Good. D is 2 because we have to improve their sales by 2 each week thereafter. So D equals 2. Do we know anything else? It kind of seems like we know. It kind of seems like we know N, don't we? What do you think N is? Yeah, it's 50. Why is it 50? There's 50 weeks, which means there's 50 terms. So N equals 50. Do we know A sub N? Can we figure out A sub N? No. Don't we know all of this stuff? Yeah, so we can figure out A sub N. A sub N equals, well actually that would be A sub 50, right? Equals A sub 1, which is 10, plus 2 times 50 minus 1. So A sub 50 equals if I distribute the 2 in, I get 100 minus 2, which is 98. 10 plus 98, which is 108. So A sub N, A sub 50 is 108. So the what does that represent? Yeah. Now notice the question. How many sales did the salesperson make in week 50? That's A sub 50, which we just found. A sub 50 equals 108 sales. And that answers the first part of that question. This guy made 108 sales in week 50. That was the first part. The second part says, how many sales did this person make in all 50 weeks? What's that asking me to do? Now I got to add all of the sales in each week up. But I have everything that I need to do that. I can just use one of my sum formulas. So that's going to be S sub 50 equals 50 times the average of the first and last terms. 10 plus 108 over 2. Did you say 108? Yeah, and I answered. It sounded like you said 4. S sub 50 equals, that looks like 5 plus 54 is 59 times 50. What do you get? Something in the 2000s. Well, 10 plus 108 would be 118 divided by 2 is 59. 2,950 sales. So that salesman was a real underachiever, bare minimum, but they still made 2,950 sales in 50 weeks. It's a lot of vacuums. Or maybe it was boxes of nerds. That would be reasonable. So we'll stop there. 8 through 14 all. It is all. So make sure you're doing all of them. Check your answers on the odd ones so that you are sure that you're doing these correctly.